Hi, I would like to give you your notes for page 38 and 39 based on systems of equations. So our goal today is I can solve a system of equations by graphing. I can solve a system of equations by graphing. So as we're looking at this, again, we have some click and drag. So when you have two or more equations with the same variables, you'll have a system of equations. So you'll see here how these both have x's, they both have y's, therefore it is a system of equations. And you find the solution to a system of equations by finding the point where the two lines cross or intersect. So over here, you'll see this example. I just took this, and here I'm going to scoot me to the other side here. I just found this image, and it kind of was boom, straight to the point. So your system of equations, you will be graphing two lines. And where the two intersect is the solution. So the majority of the systems of equations that you will work with will be this first kind. They'll have one solution, two lines intersect at one point. These are the ones that are most common. However, if you graph two lines that have the same slope, what you're going to find out is that they are parallel lines. And if parallel lines are there, they will never intersect. So parallel lines means that there would be no solution. So if you graph parallel lines, that's a no solution because they never intersect. And then you have this one over here, and this is funny because it's like you graphed a line and then you graphed the other line and they are the exact same line. So it just means one of them could have been simplified. But when they are right on top of each other, they intersect everywhere. Every single point of one line is a solution of the other one as well. And so they would have infinitely many solutions. So that's pretty much the entire lesson in a nutshell. So I thought that was a great way to just kind of just put it on there so you could see it. So looking down here to the next set of click and drag, the steps to solving a system of equations. Step 1, you're going to write each equation in slope-intercept form. The ones that we're going to do right now will already be in that form because that's the one that we have been practicing graphing so far in class. So step 1, you will want to make sure that it's in y equals mx plus b form. Step 2, I covered 2 with my graph thing, but you're going to graph both equations in the same coordinate plane. So just like up here, we saw both equations graphed. It's like doing problem number 1 and problem number 2 on the same graph. That's the only thing that's happening with this. So you're going to graph both equations on the same coordinate plane, and then you will find the point of intersection. And once you do that, you can plug them in to just check to make sure your answer is correct. So those are the steps to solving a system of equations by graphing. So now we're going to move to the next slide and do some examples. So first, we're going to type the number of solutions that match each graph. So this is pretty much going through what we did on at the front. This one has one solution because it intersects at one point. This one has no solution because they're parallel lines and they never intersect. And this one has infinite solutions because they're pretty much the same line. They're graphed on top of each other. I like this one better because you can see the red and the gray and see that they make the same line. So let's try a couple of examples. Oh, I didn't finish the last example. We are going to graph this first equation first. So we begin at 3. So you'll click your dot and you'll put it up here at 3. Remember, our beginning point is our y-intercept, and then our slope is -2. So that means we'll go down 2 and over 1. Remember, we always want our slope to look like a fraction because our slope is not a point. It is directions to the next point. And so we go down 2 over 1, and that gives us our next point. So you draw those or drop those 2 points there and then get your arrow to connect the lines. Connect the points. Then you're going to graph the same equation on the same coordinate plane. I just said that wrong. You're going to graph the next equation on the same coordinate plane. So at -7, that's our beginning point. And so we will go down here to -7. 1, 2, 3, 4, 5, 6, 7. We drop our point. That's our y-intercept. From there, we're going to look at our slope. And since it's 3, we want it to be 3 over 1. You can make any whole number look like a fraction by putting it over 1. And those are the instructions to get to the next point. So we go up 3, 1, 2, 3, over 1, and then you can connect those 2 points with your line. And then to find the solution, it's where the two intersect. So you'll see this one is here and this one is here. So they intersect right here. And I'm going to assume, since it's super duper close, it's not perfectly on this, but it's at 2, -2. The thing when you graph systems of equations is unless you are perfect and you draw perfectly straight lines or you use Desmos, like unless you do something like that, it's kind of an estimation. So it's definitely not the most accurate way to solve a system of equations, but it works. You can get a pretty good estimate. Let's try another one. Now this one I haven't finished yet, so I will finish while I'm talking to you. So you'll go up 1 and you'll drop your point because you begin with the number that's by itself. So that's your y-intercept at 1, and then your slope is 4. So you make it 4 over 1. So you go up 4, 1, 2, 3, 4, over 1. Then you're going to take one of your arrows and rotate it around and try to get it to where it will fall on both those points. Ah! Now I got to move me again. And so you'll keep doing that until you get it where it should be. You want it to go through both of them. So I'm getting closer. Oh, goodness. Okay, so that's pretty close. Then we're going to do the next one. So you'll take your point and you begin at -5. 1, 2, 3, 4, 5. So that's your beginning point, your y-intercept. So you drop your point there, and then for this one, you follow your instructions for your slope. You go down 2 because it's -2, and then over +1. So then you'll see that point. So from your beginning point, which that should drop right on the y-intercept, but it didn't for me, but it's close enough. Then we'll take this and we are going to make it go through both of those points. Getting a little closer here. And then you'll be able to type in your solution here where the two intersect. And it looks like they are going to intersect right there at the y-intercept. So they'll intersect at 0, -5. Because if you remember, my point was supposed to be over just a little, and that's where the two lines intersect. So those are your notes for today. This is definitely easier to do through Math Excel than it is using Google Slides. So I hope that you will be successful on your assignment. I balanced it with some of the things that we've been practicing with M and B and graphing one line. And then I just put a couple of them with systems of equations. So good luck, and please let me know if you have any questions.